Hello everyone, welcome to the Extending Apex Apps with Autonomous Database workshop. I hope everyone is doing well. My name is Bo English Fitchling. I'm a director on the Oracle Apex team and I'll be your guide and presenter for today's workshop. I'm very excited to show you some innovative new technologies that you can take advantage of to extend Apex using Autonomous Database, including spatial, machine learning, and security. First, I'd like to introduce some folks that are helping with today's workshop. You'll see presentations from Jerome, who's a product strategy manager for Oracle Digital, David, who's a principal PM on the spatial and graph team, and Juan, who's a senior solution architect from Oracle Digital. We also have several panelists who will be answering your questions behind the scenes. Here's the agenda. Today we're going to cover the introduction, spatial, machine learning, and security exercises, which are labs 1 through 4. These 4 exercises are going to kick off with a pre-recorded presentation that gives you the most amount of info in the shortest amount of time, and then you'll get hands-on experience following each lab. We'll spend about 2 hours in today's session covering all 4 labs, and you may not complete all 4 exercises today, but don't worry, you can work on those at your own pace, and we'll hold another one of these sessions in the future if you'd like to join again. If you have any questions, please post those in the Q&A section in Zoom, not in chat, and one of the panelists will answer. Please remember to put all of the information in one question and include the region name, database version, the page and step of the lab guide, and any error message text so we can support you properly. Also, I just want to remind everyone to please read carefully and follow every step in the lab. Please do not skim. Each step is required for your labs to work properly. So if your lab is not working, please check to ensure you've followed every step first before posting a question. You'll see 2 bit.ly links on your screen. The first link is to create a free trial account, and the second link is to view the lab guide. If you've already created your free cloud account, then please click on the lab guide link to start the exercises. Just a reminder, post any questions in the Q&A and one of our panelists will answer. This exercise should take you about 10 minutes, so we'll see you live in 10. Welcome back. If you didn't finish lab 1, that's okay. Please work on that at your own pace. Before we go to lab 2, we'd like to share a little bit about what Autonomous is with our first presentation. We'll see you here in a few. Hi, in this workshop, we're going to cover what Autonomous Database is and how to extend Apex applications with some exciting new features that come with Autonomous. Let's begin with a quick intro on Autonomous Database. Autonomous Database essentially automates the database and infrastructure management so you don't have to spend time installing, securing, patching, tuning, and backing up the database. But before we even get to the database, there's the infrastructure and preparation of the hardware, installation of the operating system, and many more things that you've got to prepare. And with Autonomous Database, all of this is now automated. Not only does this save you time and money, but it also makes it more secure by removing human error. The journey of Autonomous Database has been an evolution, and Oracle's been improving the database and hardware over time. Oracle spent the last decade working on the database infrastructure with our engineered systems, introducing innovation and automation at the infrastructure level. You've probably heard of Exadata. It's our best performing, most available, and most secure architecture for running Oracle databases. An Autonomous Database is a combination of all of these evolutions, which includes infrastructure, database, and cloud. And since all of these are highly automated in just a few mouse clicks, you can create and run databases, and everything is managed for you by Oracle. When you provision an Autonomous Database, you get a mission-critical database, which includes all of the advanced technologies that we previously mentioned. You get Exadata. The operating system is created for you. The database is automatically created. And it includes Active Data Guard, which creates a copy of your database in another region, so you can recover in the event of a failure. So running an Apex application on Autonomous isn't just about saving time. It's an upgrade to mission-critical database features that we previously used to only find in large enterprises. But now, everyone has access to all of these innovative features. Now let's talk about security. As new security patches become available, these are immediately applied while the database is still running and without any human intervention. So this prevents any delays, downtimes, and human error. Once your database is up and running, Oracle monitors the health of all the systems behind the scenes. Using machine learning algorithms, Oracle can detect and remediate any problems before they occur. And if any patches are required, these are also automatically applied. Again, all this occurs while your database is up and running. Autonomous also has various mechanisms which protects against failure. First, there are automatic backups. And then we protect against failures both within the scale-out clusters and other regions using DataGuard mentioned earlier. Should any failover happen, it will occur in such a way that your application will never notice. If you're in a situation where your Apex application suddenly requires more performance of the database, then you can easily scale up or scale down. This is, of course, one of the great benefits of the cloud. You don't have to purchase a big piece of hardware just to handle your peak workloads. You can choose when to scale up or let the database decide. So even that is automated for you. What this means is that you or your customer is only paying for the computing power that you really need. Now let's talk about the optimization of the database. Autonomous databases uses machine learning to optimize database workloads. The Oracle database always had planned optimizers to improve query and DML performance, but even so, there was always work to be done for the DBA and application developer. Now, this auto-tuning goes even further because the database itself continuously manages things such as memory and parallelism. When you create an autonomous database, you can choose one of two types of workloads. There is Autonomous Data Warehouse, which is optimized for analytical querying. For example, one of the optimizations here is to have all of the data stored in columnar format, and most of the internal memory is used for parallel joins and aggregations, because that's the most efficient way for analytical querying. And then there's Autonomous Transaction Processing, or ATP. This is optimized for your daily operational applications. So here the data is stored in regular row format. And most of the internal memory is used for caching to avoid I/O and to get faster response times that operational apps typically need. Most Apex applications will fit into this transaction processing category, but we know that there are some folks using Apex primarily for reporting. However, in this workshop, we're going to focus on ATP. I mentioned already that Autonomous comes bundled and pre-configured with various features that were previously only available as add-ons or database options. Most of these were not visible to the end user. But Autonomous comes bundled with some features that can add functionality that are actually visible in your application. For example, you can leverage advanced security features to mask sensitive data such as credit card information. You can add geographical functionality to your apps using Spatial. You can even add machine learning to train models to make predictions and then integrate them into your Apex applications. So let's summarize how Apex and Autonomous works together. Both are built on the principle of saving you time so you can focus on more interesting things, not maintenance. Apex allows you to build applications quickly, and Autonomous Database has the same purpose by allowing Oracle to manage the infrastructure and database for you, which leaves you time for real innovation and application development. Once the app is delivered, you'll also save time that would normally have been spent maintaining the infrastructure and keeping the database running. Autonomous is also a great match if you're looking to use Apex for mission-critical applications and if your applications need to be more performant. If availability or failover is important, or if you're looking for a higher standard of security, this can be a great match. Last but not least, we can extend Apex applications with new functionality that comes bundled. And we will spend most of the time on these new features. Thanks for your time, and we hope you enjoy these labs. Hello all, welcome back. If you did not complete Lab 1, that's okay. Please work on that at your own pace. The next topic is Spatial, and the next video will be presented by David Lapp, the Principal PM for Spatial and Graph. This video will take about 10 minutes, so we'll see you live in 10.
Hi, my name is David Lapp. I'm a product manager on the Oracle Spatial and Graph team, and I'm going to run through a quick overview of the spatial features of Oracle Spatial and Graph that you'll be including in your Apex workshop. Quick safe harbor, I'm really not talking about any futures here, so not a major concern. So the spatial platform as a whole is really all about having spatial features that are a built-in part of IT infrastructure in the Oracle stack, database, middle tier. Non-functional requirements, security, scalability, etc., are handled by the infrastructure. You don't have to deal with that separately, and we support the common languages that make application development simple. Our strategy on the whole is to have spatial capabilities across all the Oracle platforms. So we'll be focusing on database features. We have features in the big data platform, and our features exist across the Oracle Public Cloud, particularly the spatial database features on the database cloud service platforms I have listed here. The high view of Oracle Spatial and Graph features really boils down to the fact that we support storing natively all these types of spatial and graph types within the database: basic points, lines, polygons, points like address locations, lines like utility lines, polygons like sales regions, and then advanced features tracking network modeling, various graphs, 3D, etc., all in the database. And along with that, a series of deployable components or apps that you deploy to do map visualization, address geocoding, etc. This platform is uniquely open and interoperable, supported across the whole geospatial industry. The GIS tools, the ETL tools, the sort of engineering-related tools, open source, commercial, they all support our spatial platform. And the real essence of what this is about is, again, storing spatial data natively in the database, indexing it, and performing queries like we see below, where we want to find all the customers that are within, in this case, 10 miles of a hurricane path, using a basic SQL statement with a spatial operator. Nothing really new to learn here. It's just standard SQL that understands spatial. So taking a quick look at sort of some of the specifics. If we describe a table that has geometry, it's just another column in a table, and the data type is this thing called mdsys.sdo_geometry, just our native geometry type. On the right, I can select a geometry. We can see what it looks like. It's just a built-in native object data type that has information, including identifiers to specify what type of geometry it is. Here, this is a two-dimensional polygon, and you can see the latitude, longitude coordinates that make up that shape. In this case, it's the shape of Aruba. We can start to do queries, like in this case, I want to find which facilities in a facilities table are located within a countries table, and in particular, which facilities are inside Belize. And this is just a simple query using an inside operator to give me the answer to that question. I can also do spatial queries where a location is defined at runtime by constructing a geometry on the fly. Here, what is the country from a countries table that contains a point that I'm just defining at runtime with a longitude and latitude? In this case, the point's in Mexico. This is the type of query where the location, this point runtime location, could be supplied in an Apex application by user input or a mouse click. So we can do these types of spatial queries with runtime as well. Those are the very, very basics around a couple of spatial operations, but spatial on a whole has a huge array of both general purpose and highly specialized spatial functions and operators, way beyond what you'll have time to look at here, but just know that our portfolio is really vast in terms of spatial analytics. It's also worth mentioning, especially from the development perspective, that the JSON features of the database are really inherited and extended with spatial, so that built-in JSON functions in the database, like JSON value, know how to return a geometry if that JSON is GeoJSON. And we also have convenience functions to seamlessly translate back and forth between GeoJSON and our native spatial type. So development dealing with JSON is seamless when it comes to spatial. Spatial also includes a map visualization component. Some of you may have heard of Oracle Map Viewer, which is what this is now called. It's feature and ships with Spatial, and it's a map server and JavaScript client for high-performance map visualizations in web applications and in mobile. It comes with both the map server and the client, but also a map authoring tool to define map layers and styles to look and feel in a web-based administration console, and allows you to create just really nice looking, highly interactive web-based mapping apps. So putting all this together between the storage, the features in the database to store and analyze geometry, along with both your own and commercial map content from our partners like TomTom and here, along with the map visualization, map server, and client, you have a stack to easily create mapping applications. Those range from everything from just basic general purpose business applications with a spatial component for basic map visualization, geocoding, basic sorts of spatial analysis, through to advanced geospatial apps for city modeling using 3D and LiDAR, sophisticated multimodal routing applications, and so on and so forth. In addition, our spatial features are baked into Oracle products, our development tools, SQL Developer, of course, Apex, which is what this session is going to be focusing on, and I'll get back to that in a moment. But also our analytics cloud platform, Oracle apps like our utility applications, our transportation management applications, and our mobile apps. Another new feature of Oracle Spatial is something called Spatial Studio. Traditionally, access to spatial features was through coding, SQL, PL SQL, etc., and web-based coding. Spatial Studio is our self-service sort of casual business user tool to access those spatial features. So it allows you to connect to spatial data, prepare data with geocoding and coordinate indexing if it's not already spatial, do spatial analyses, share your work, create a map visualization app, and share it. Very simple self-service. So again, allows you to handle access and preparation of spatial data, create projects to be able to visualize and share your results. In your Apex spatial exercise, the polygons and regions you're going to be dealing with have been prepared to allow you to look at and interact with them in Spatial Studio. So you're going to see this. So to conclude, I just want to point out where this rubber meets the road with Apex. So a few things. First of all, because this is just SQL and PL SQL APIs and operations in the database, you can include all kinds of really useful spatial functionality within regions in your Apex app just by adding spatial to your SQL. Things like containment, which locations are inside or outside of a region, what's the nearest, et cetera, et cetera. And spatial calculations like distance and length and so forth, you could just include via SQL. You can also leverage the built-in Apex Spatial package to perform routine metadata management functions. Spatial data, when you are going to create and persist it, requires some spatial metadata to be created, and this built-in Apex package makes that really easy, as well as doing handling the construction of basic spatial objects that you'd want to persist and maintain. So that's a convenient function that's built into Apex. And then finally, I encourage you to install the sample geolocation showcase, which is one of the bundled apps in the app gallery. And that has a lot of great stuff, including a series of Oracle supplied spatial and mapping plugins, as well as examples of pages that show all kinds of spatial analysis and map rendering. Finally, I'll just mention a few resources. Our product portal on oracle.com. We're pretty active in blogging. Our forum, which is where you can ask questions and sort of hear what other people are asking about. And finally, our communities. So I hope you are encouraged here to carry on and learn more about spatial, and in particular, the way spatial can be used within Apex. Thanks.
Hello again. In this exercise, we'll focus on adding spatial to your Apex application. Please follow the instructions in the bit.ly link for Lab 2. Just a reminder, post any questions in the Q&A and one of our panelists will answer. This exercise should take you about 20 minutes, so we'll see you live in 20. Hello again. Let's go to the next topic on security from Juan Cabrera, Senior Solutions Architect from Oracle Digital, and I'll see you back here in about 2 minutes.
Hola, my name is Juan Cabrera, and I am a Solutions Architect in Oracle specialized in the Autonomous database. The Autonomous philosophy comes hand in hand with database security. Think about security patches, for example. Keeping them up to date continuously is a very cumbersome activity. But in the scope of the ATP and its self-securing approach, the latest security patches will be applied transparently to our databases, and we can be sure that the best industry practices will be respected. Hey, but there is much more about security than patches. Transparent data encryption and data redaction are two very powerful features to protect our application data. Transparent data encryption allows to secure our data transparently at the storage level. This means that even if an attacker gains access to the physical machine, our data will still be safe. Data redaction, on the other side, makes sure our sensitive data is protected even before it leaves our database and is sent to the application. During our lab, we will use it to show only the last 4 digits of a credit card column in our application, without needing to handle security on the application side. Both are native to the ATP. That's due to the presence of the advanced security option, and we're going to see them in action in this exercise. I hope you enjoy it.
Welcome back. In this exercise, we'll focus on adding security to your Apex app. Please follow the instructions in the bit.ly link for Lab 4. Just a reminder to post any questions in the Q&A, not in chat, and one of our panelists will answer. This exercise should take about 20 minutes, so we'll see. Thanks again for attending our Extending Apex Apps with Autonomous Database workshop, and I'd like to thank all the presenters and panelists that participated today. You'll see some links on your screen where you can find additional information about Apex and Autonomous Database. Please don't forget to follow us on social media. And if you did not finish all the labs today, that's okay. Please work on those at your own pace. Thank you again for attending.